today we're starting the first of a few days of trig proofs. So you'll notice notes V-1, trig proofs day 1. So a couple of things before we begin. Show all work. That's the point of proofs. So your reader, who may or may not be me, doesn't know you necessarily, and they don't know what you know. So you really have to show everything that you're doing to prove that one side of the equation equals the other. So no skipping steps today. Sorry about that. So for the proofs, show all your work. That's the point. So you should have with you next to you the spring formula card, your printout of the spring formula card. We're going to be using reciprocal properties, quotient properties, and Pythagorean properties today. So when I put down on here Pythagorean property number 2, that means I use this property. Now remember, on these Pythagorean properties, you can manipulate this in a way that works for you. So yeah, sure, secant squared x equals 1 plus tan squared x. But if you wanted it to be what tangent squared x equals, you could move the 1 to the other side and it'd say tan squared x equals secant squared x minus 1. So same with this, you can manipulate this to solve for cotangent squared x, and same for these. So these can be manipulated some, so just be aware that the property you use may not look exactly like this. It may be manipulated in some way. So let's start with number 1. So on number 1, cosine of x tan of x equals sine of x. So keep copying the right side all the way down. Don't change it. The left is what you can work with. Okay, the right, however, you're checking, you're verifying that this side equals this side. One of the sides has to stay the same. So we will keep the right side the same all the way down. Okay, so on the left here, you'll notice that I'm going to write what I'm doing to get to that final answer. Okay, so this isn't steps for, oh, I can follow these steps every single time. No, what I need you to understand is you're going to fail every now and again with this. You're going to start working and you're going to get something and you'll be like, oh, darn it, that didn't work. You're right. It doesn't work every single time. Now, of course, I've been doing this a long time, as well as these are notes and I don't want them to take forever. So I'm going to do it the right way, typically the first time, okay? So you won't see me making too many mistakes throughout, but be aware when you do this on your own, this is not a step-by-step process that you follow this every single time. No, you're going to have to find the way that works with the problem, and there's going to obviously be more than one way that works, so just be patient with yourself and be patient with the process. Okay, so like I said, keep the right the same. We're changing the left. Now, this is something true unless your right side is not one of the basics. So on the right side, you have a basic sine and or cosine. You want to change anything that's not sine or cosine to a basic. Okay, so basics are sine and cosine, not tangent. So what we're going to do first is we have cosine of x times tangent of x. Well, this means the same thing as cosine of x times tangent is sine of x over cosine of x, okay? And that equals, remember, keep dragging down the right, sine of x. Well, fancy that. What happens here? So your cosine and cosine simplify, so then you get sine of x equals sine of x. So check and check. Of course, that's correct. So this part right here is required. Your final answer should look like the left side equals the right side. That's how proofs should look. Okay, so let's look at number 2. Of course, a little bit more difficult. So sine squared of x, secant squared of x, cosecant of x, and tangent equals tangent of x. So prove that sine squared of x, secant of x, cosecant of x equals tangent of x. So these right next to each other means multiplication. I've just left some space so we can kind of work. So this is what I'm going to follow on this one. And again, I've written this before just because I've solved this and I already know. So basics expand. That should typically be your first step. So basics meaning something like secant can't stay secant. Something like cosecant can't stay cosecant. Okay, expand meaning sine squared of x means sine of x times another sine of x. So let's break it up just in case. And we might be doing it for no reason. It might be useless, but we're going to do it in the beginning just to see where that gets us. So Sine squared of x means sine of x, sine of x. And then secant, of course, is 1 over cosine of x. And cosecant of x is 1 over sine of x. So aren't you glad we expanded? And of course, I'm going to copy the right. Aren't you glad we expanded? Because look what happens. One of these sine of x simplifies with one of these sine of x. And then slide. We call this slide because these kind of slide together. So this times this would become sine of x. Oops, here I'm going to sine of x on top over cosine of x. So that's what we're left with. Slide it all together. All right, equals tangent of x. Is that true? Well, sure it is. You have the quotient property number 1 on your list here, that tangent of x equals sine of x over cosine of x. So that quotient property tells us that tan of x equals tan of x. Yay, number 2 down. We're good. All right, so that was our quotient property. That right there, going to that, was our quotient property number 1. All right, so now number 3, cosine of x multiplied by secant of x plus cosine of x cosecant squared of x should equal cosecant squared of x. Okay, so on this, just like you would think a normal algebra problem, you're going to want to distribute to see what this gets us. So this is 2 terms here. I want you to understand this will get multiplied by this, and then this will get multiplied by this, not twice into this, because that'd be multiplying twice into the same term. So when I distribute, boom and boom, okay, I get cosine x secant x plus, this is going to become cosine squared x cosecant squared x should equal cosecant squared of x. So I distributed, check, reciprocal pair. Okay, so here we have cosine multiplied by secant. Those are a reciprocal pair. So that, my friends, turns into 1. 1. Okay, so 1 plus, okay, so this is cosine squared x cosecant squared x. So let's cosine x, let's expand, basics and expand. Cosine x times cosine x, times 1 over sine of x times 1 over sine of x. Because cosine squared means I've got 2 cosines. Cosecant, remember, is 1 over sine. So 1 over sine times 1 over sine because it's squared. So then I've expanded. Does anything simplify here? No, I do need to drag down the cosecant squared of x. No, nothing simplifies out, but now I want to slide back. So let's change this up a bit and say that this is 1 plus cosine x over sine of x times cosine x over sine of x, right? So put those together, and then you should see, oh, course equals cosecant squared x. You should say, oh, what is cosine x over sine x? Well, go back to your quotient property number 2. And cotangent of x is equal to cosine of x over sine of x. So quotient property number 2 brings us to 1 plus, this is cotangent x times cotangent x equals cosecant squared x. All right, still dragging along the right. So this is like 1 plus cotangent squared x equals cosecant squared x. And what do you know? The Pythagorean property number 3 is cotangent squared of x plus 1 equals cosecant squared of x. So that means this right here becomes cosecant squared of x because of that Pythagorean property number 3. So check and check. All right. So then let's look at our last problem here, problem number 4. Okay, let me get all this stuff in order. So on this one, the first thing I notice right away is that you have a GCF. Okay, your GCF here between these two is cosecant squared of x. Both of these terms have cosecant squared of x. So you're going to factor out your GCF of cosecant squared of x. If you factor out cosecant squared of x from this term, of course you're left with 1 minus, factor out cosecant squared of x from this term, cosine squared x. And that should equal 1. Now, of course, if you distribute back, you should notice it'll get you back to the original. Okay, and the reason that was useful is because then look what you're left with. This 1 minus cosine squared of x. Look at Pythagorean property number 1. Okay, so if you have manipulated this to be 1 minus cosine squared of x, that would equal sine squared of x. Why is that useful, you might think? Well, think about what cosecant is. So if this is sine squared of x, has to equal 1. All right, if this right here has become sine squared of x because of Pythagorean property number 1, think about cosecant and sine. What's their relationship? They're a reciprocal pair. So you really have here 1 squared because their relationship is that they're reciprocals. So that would be 1, and then of course it's squared. All right, but 1 squared is 1. So does 1 equal 1? Why, yes, it does.